Section 3.4, Graphing Linear Inequalities. Let's go through these symbols one more time just to make sure everybody remembers these symbols. The first one is less than, strictly less than. The one down below is greater than, again strictly greater than. So we will not include those starting or ending points because we either have to be less than or greater than. On the right hand side we have less than or equal to, and the one below it would be the greater than or equal to. So therefore we could be equal to the number or less than, or we could be equal to the number or greater than. So either of those would satisfy the inequalities. So how do we graph linear inequalities? We have a lot more solutions that will work than just say a linear equation. With linear equations we had one solution. For graphing linear inequalities, we're going to have to think about shading to show all the different ordered pairs that actually work. So first things first, to graph the linear inequality, the first thing you want to do is graph the line using any method from page 8. So you can graph the line using any method from page 8. For example, table method, slope-intercept form, or finding the intercepts. Next, you need to decide if the line should be dotted or solid. Now how we will decide if a line is dotted or solid is by looking at the inequalities. If we're strictly less than or strictly greater than, we are going to use a dotted line. Now why? Because that means the points on that line will not satisfy the inequality, so it must be dotted. However, if we have a less than or equal to or greater than or equal to, then we're going to use a solid line, which means all the points on that line will also satisfy the inequality. Next thing you'll have to do is you'll choose a test point. The test point that I like to choose most often is the origin 0, 0. But if our line goes through 0, 0, we'll have to choose a different test point. Now once you choose a test point, you plug it back into the original inequality. If the test point satisfies the inequality, shade where the test point is. But if the test point does not satisfy the inequality, then you're going to shade on the other side of the line. So if it satisfies, shade where it is. If it doesn't satisfy, shade on the opposite side. The first thing I want to make sure of is, do you understand what it means to satisfy an inequality? So for example, number 1, does 0, negative 3 satisfy x minus y being greater than or equal to 5? Our x would be 0 and our y would be negative 3. So we'll plug in those values and see, does that satisfy the inequality? So we'll end up with 0 minus a negative 3 is supposed to be greater than or equal to 5. And I'll put a question mark because I'm not sure if that's right. If I look at that, I get 0 plus 3 is supposed to be greater than or equal to 5, which is false. So does 0, negative 3 satisfy that inequality? No. So if that's my test point, I would not shade where that point is. So now let's graph the following inequalities. Number 2, y is less than or equal to negative x plus 5. First, we're going to pretend we have an equal sign. I'm going to pretend I have an equal sign because then it might be a little bit easier for me to graph the inequality. So this is in the form of y equals mx plus b, which means I'm going to begin at 5 and use my slope to get to the next point. 5 is the y-intercept, so I'll put a dot at 5. My slope is negative 1, so that's going to tell me to go down 1 and then to the right 1. Down 1, right 1, down 1, right 1. So then I have to see, am I going to draw a solid line or a dotted line? And that's when we look at the inequality. The inequality had a less than or equal to, so I know that I'm going to have a solid line because of that equal sign below the inequality. Next, I'm going to need a test point. And if I look at my graph, I see that my line did not go through 0, 0. So I'm going to use the test point 0, 0. Now anytime you test, always go back to the original inequality. So my original inequality was y being less than or equal to negative x plus 5. Plugging in 0, 0, I want to find out, is 0 less than or equal to negative 0 plus 5? And 0 is less than or equal to 5, so that does check out. So my test point, which is right there at 0, 0, is a yes, which means all of these points underneath this graph would also work. So therefore, I would shade everything below that line. So what this means is that all points on the line plus all the points that are below the line would satisfy that inequality. Number 3. 2x minus 3y is less than negative 6. Looking back at page 8, I can also learn to graph equations by finding the intercepts. So I'm going to pretend that we have an equal sign. And I'm going to find my x-intercept by letting y be 0. I'm going to find my y-intercept by letting x be 0. If you want to put it into slope-intercept form, go right ahead. So if I put a 0 in for y, I end up with 2x equaling negative 6. So my x-intercept is going to be negative 3. So negative 3, 0. If I put a 0 in for x to find my y-intercept, I get negative 3y equals negative 6. So y is going to equal positive 2. So I have an x-intercept of negative 3, 0 and a y-intercept of 0, 2. So negative 3, 0 is there and 0, 2 is right there. We'll then need to decide, is it a solid or dotted line? Looking at the original inequality, I see that that has to be strictly less than. So I need to draw a dotted line through those 2 points. Next, I need to choose a test point. Again, since my graph did not go through 0, 0, I'm going to choose a test point 0, 0. And where should I plug it back into? The original inequality. My original inequality was 2x minus 3y is supposed to be less than negative 6. Plugging in a 0, I get 2 times 0 minus 3 times 0 is supposed to be less than negative 6. 2 times 0 is 0, 3 times 0 is 0, so I get 0 is less than negative 6. And that is false. So that means none of these points down here should work. So where should I shade? On the other side. And again, we can choose a test point and check it just to make sure. Let's try number 4, y being greater than 2/3 x. This is in the form of y equals mx plus b if we pretend we have an equal sign. The b is not there, so the b has to be 0. So I'll start at 0. My slope is 2/3, so that tells me I will go up 2 and then to the right 3. Up 2 and to the right 3. Then I'll have to decide should it be solid or dotted. Looking back at my inequality, I see that it is strictly greater than, so it's got to be a dotted line going through those points. Now as you see, we went through 0, 0, so I cannot do a test point 0, 0. My test point has to be something other than a point that is on my dotted line. So I'm just going to choose another point. I'll choose that one, 3, 0. You can choose whatever point you want. Just make sure you are a little farther away from your line just to make sure. So plugging in 3, 0, that means x is going to be 3 and y is going to be 0. I get 0 is greater than 2/3 times 3. And I want to know, is that true? So I'll put a question mark. 3 times 2/3 is actually just 2. And is 0 greater than 2? No. So 3, 0 did not work. So none of these points are going to work down here. So where should I shade? Above my dotted line. So this means all the points above the line will work, but I cannot use the points on the line. So number 5, 3x plus y is less than or equal to 0. This is actually in the form for me to find my x and y intercept. But if you do the math, to find the x-intercept you let y be 0, to find the y-intercept you let x be 0, you're actually going to end up with 0 and a 0. So that only gives me 1 point. So that method in a sense failed because you need 2 points to draw a line. So I'm going to put it in y equals mx plus b form just by subtracting over the 3x. So I still see that my y-intercept is 0, but now I know my slope is negative 3. So that can tell me to go down 3 and to the right 1. So down 3, right 1, down 3, right 1. Then we have to decide should it be solid or dotted. So looking back at our original inequality, we have less than or equal to, so we know it's going to be a solid line going through those points. Again, we are going through 0, 0, so we cannot do a test point of 0, 0. So I will choose a test point, say 2, 0. So 2 zeros right there. I'll use that as my test point. So test point will be 2, 0. Again, you can choose whatever point you want. Plugging in value for x and y, I get 3 times 2 plus 0 is supposed to be less than or equal to 0. Is that true? Well, 3 times 2 is 6. Is 6 less than or equal to 0? No. So 2, 0 did not work, so none of those points will work on that side. So I should shade on the other side. Again, choose a test point on the left side of the line, and you see that those points will satisfy the inequality. Number 6, x is greater than or equal to negative 2. If I pretend I have an equal sign, I have x equaling negative 2. We only have a one variable equation. Looking back at our notes, when we have a one variable equation, it's either horizontal or vertical. Well, this one says that x always has to be negative 2. So no matter what y is, x has to be negative 2. So x being negative 2 would actually make a vertical line. Is it solid or dotted? So we go back to the inequality, and we say that the inequality shows that it is solid. So I'll draw a solid line on x equaling negative 2. Test point, we could say 0, 0, but we only need to plug in a 0 for x. Is 0 greater than or equal to negative 2? That is true, which means since 0 worked, all the points to the right should work, so I should shade on the right-hand side. Number 7, y is less than 5. Again, if we pretend that we have an equal sign, y equaling 5, I will look at a table. That means y is always going to be 5. Doesn't matter what x is. So y being 5 would make a horizontal line. We look to see if we have a solid or dotted line. That shows we have a dotted line because it's strictly less than. So we're going to dot along y equaling 5. Test point would be 0. So if I try plugging in 0 for y, is 0 less than 5? That is true. So that means all the points below the line are yes. So this is where I should shade.